Hello again, everybody, and welcome to this lesson about the last 3 points on our chapter, the particulate nature of matter. So, during this video, we will be studying a description, or we will be describing qualitatively the pressure and the temperature of a gas in terms of the motion of its particles. Then we will show an understanding of the random motion of particles in a suspension, which is sometimes known as the Brownian motion. Then we will be giving a description and we will be explaining diffusion. Okay, so as we discussed before, when we talked about the random motion of particles, okay, we said that the particles are far apart and they move quickly. While we talked about the gases, they move by around 500 meters per second in all the directions, and then they collide with each other and with the sides or with the walls of the container. Okay, so this movement and this colliding with the sides or the walls of the container is what create pressure. So this is how pressure is created inside a can of gas, for example. Okay, so this heating of the particles to the walls or the sides of the container is creating pressure inside this container. And as you can see here in this image, in the left, we can see that we have two containers which are containing two lids. In this one, we will be pushing down this lid. Okay, so by doing this, we will be decreasing the volume. As you can see in this image, we have the same number of particles. In this part here, those particles are particles of gas. Okay, so they are moving randomly, but they are hitting the sides of the wall. So in this case, we have a pressure, but by decreasing the volume, we are forcing those particles to hit the walls more frequently than this one here. Okay, so this will increase the pressure inside this container here. Okay, so by decreasing the volume, we are forcing those particles to hit the walls of our container, which will increase the pressure. Okay, good. Now let's see the effect of temperature. Now let's keep the volume constant in both containers. Okay, so as you can see on this left one here, when we don't heat the particles are moving randomly. Okay, because we are pretending that we have a gas here. Now by heating this container, the particles of the gas, they will gain energy, okay, a kinetic energy, so their movement will increase, and then they will be moving frequently and randomly, hitting the walls of this container. So this will increase the pressure inside this container. So we can conclude that the higher the pressure, okay, the more motion of gas particles. Then also the higher the temperature, or by increasing the temperature, the more motion of the gas particles. Okay, good. Now let's try to take a look on the Bronian motion. Okay, so in this part here, we will be showing we will be trying to show an understanding of the random motion of particles in a suspension. Okay, so in this image here on the left, you can see here that we have particles of dust which are dancing, let's say dancing in the sunlight. Okay, so you all asked yourself before why those particles of dust are moving randomly like that. So the idea behind that is actually those dust particles are in or are colliding with the particles of the gas, which you cannot see by your eye. Okay, they are colliding randomly with the particles of the gas, with the particles of the gas, so they have this random movement. Okay, and actually this is what we call the Brownian motion. Okay, so we can see also here in this image that this is actually an experiment done by the Scottish botanist Robert Brown in 1827, and he looked through his microscope at pollen grains suspended in water. The pollen grains are those yellow particles, and those black particles moving here are the particles of water. As you can see in this image here, that the yellow particles are moving randomly. This is due to what? This is due to their collision with the particles of water. Okay, so they collide with the particles of water. This is what allowed them to move randomly also. So the particles in a liquid or in a gas, which are known as fluids, move randomly. Okay, so this random movement of particles inside a fluid is what we call the Brownian motion. Okay, now on the last point, let's try here to describe and explain what we call diffusion. Okay, so diffusion is the process by which different fluids mix as a result of random motion of their particles. Okay, so diffusion generally involves the movement of particles from a region of higher concentration towards a region of lower concentration. As you can see here in this image, we have the diffusion of potassium permanganate in water as it dissolves. Here, the potassium permanganate crystals are in diffusion inside this water. Okay, so here eventually the particles are evenly spread. Then, as a result, their concentration is the same throughout. Okay, say that therefore diffusion does not occur in solids since the particles cannot move from place to place, because the particles in solid, they only vibrate. That's it. Okay, so thank you for watching, and till next video. Bye for now.